This is Srinivasan, Assistant Professor, Department of ECE. In this presentation, we are going to discuss on decoder, encoder, priority encoder. A binary code of n bits is capable of representing up to 2 to the power n distinct elements of coded information. A decoder is a combinational circuit that converts binary informations from n input lines to a maximum of 2 to the power n unique output lines. A 3 to 8 line decoder, a circuit that is shown in the figure, will have 8 outputs, each representing one of the minterms of 3 input variables. An application of decoder is binary to octal conversion, where the input variables represents a binary number and the outputs represent the 8 digits of the number in the octal number system. However, a 3 to 8 line decoder can be used for decoding any 3-bit code to provide 8 outputs, 1 elements for the code. So a 3 to 8 line decoder, the 3 inputs are X, Y and Z, which will provide D0, D1, D2, D3, D4, D5, D6, D7, and D0 is equal to X dash, Y dash, Z dash, and D1 is equal to X dash, Y dash, Z, and D2 is equal to X dash, Y, Z dash, D3 is equal to X dash, Y, Z, D4 is equal to X, Y dash, Z dash, D5 is equal to X, Y dash, Z, and D6 is equal to X, Y, Z dash, and D7 is equal to X, Y, and Z. So 3 input variables and 8 outputs. For each possible input combination, there are 7 outputs that are equal to 0 and only 1 is equal to 1, which means any one of the output will be produced as 1. The output whose value is equal to 1 represents the minterm equivalent of the binary number currently available in the input lines. So how to implement a full adder using a 3x8 decoder? So when you use a 3x8 decoder for 3 input variables, it will produce 8 minterms. And you are aware, for a full adder circuit, sum is equal to summation of 1, 2, 4, 7, and carry is equal to 3, 5, 6, 7. So by using the minterms produced by the decoder, we can OR the 4 minterms to produce the sum and the 4 minterms to produce the carry. Encoder. An encoder is a digital circuit that performs the inverse operation of a decoder. A encoder has 2 to the power n input lines and n output lines. The output lines generate the binary code corresponding to the input value. An example of the encoder is octal to binary encoder, whose truth table is given in the table. It has 8 inputs and it produces a corresponding binary number with 3 outputs. The encoder can be implemented with OR gates. So from the truth table, we can obtain Z is equal to D1 plus D3 plus D5 plus D7, Y is equal to D2 plus D3 plus D6 plus D7, X is equal to D4 plus D5 plus D6 plus D7. And they can be implemented by using 3 OR gates, where Z is equal to D1 plus D3 plus D5 D7, and Y is equal to D2 plus D3 plus D6 plus D7, and X is equal to D4 plus D5 plus D6 and D7 in the logical circuit. Next, we move on to the priority encoder. When it comes to encoder, so any one of the bit is 1 with respect to the inputs, but in real time application, so it is not so. So we may have more than 1 inputs to be equal to 1. So a priority encoder is an encoder circuit that includes the priority function. The operation of priority encoder is such that if 2 or more inputs are equal to 1 at the same time, the input having the highest priority will take precedence. The truth table of a 4 input priority encoder is given in the table. In addition to the 2 outputs X and Y, the circuit has a third output designated as V, which is a valid bit indicator. So if this is set to 1, when 1 or more inputs are equal to 1, it indicates that it is a valid bit to proceed further. So let's go with the truth table 0, 0, 0, 0, and you can check that V is equal to 0 because the input is not a valid input, because any one bit should be 1. When it comes to the next input sequence, 1 0 0 0, so it is a valid input. X 1 0 0, x can take a value 0 or 1, again it is a valid input. X 1 0, again it is a valid input. X 1, again it is a valid input. If the input is 1 0 0 0, x and y will be equal to 0 0. If the input is x1 0 0, the output x and y will be 0 1. If the input is xx 1 0, the output will be 1 0. If the input is xx 1, the output will be 1 1. So this is the truth table for different combinations of D0, D1, D2 and D3, and we obtain the outputs as x, y and v. By using a K-map simplification, we can obtain x is equal to D2 plus D3, y is equal to D3 plus D1 D2 dash, and v is equal to D0 plus D1 plus D2 D3. And we have implemented the 4-bit input priority encoder by using the logic gates OR, and NOT gates. So we provide the inputs D3, D2, D1, D0, and we obtain the outputs as x, y and v, which refers to the valid input.